All right, so the difference between period. Period is the time to make one circle. Frequency is the number of circles that have happened or would have happened in a unit of time. Period is measured in seconds with the symbol capital T. Frequency is lowercase f, measured in hertz or cycles per second. Circle to indicate whether each quantity is frequency, period, or other. Okay. Because we don't have enough videos in this section, let's go ahead and get to it. Maybe. The second hand of a clock takes 60 seconds to travel around the clock. 60 seconds to go all the way around the clock. That is period. The hour hand of a clock travels around the clock twice a day. That's number of circles per unit time. So that is our frequency. Each second as it orbits, the Earth travels 18 miles. "18" is not frequency or period. It is other, and the other is going to be speed. It's a distance, and this time is given to us as seconds. So the Earth rotates 30 times every month. That is circles per unit time, so that is frequency. The Earth takes 365 days to complete one full orbit. That is the time for one circle, so that's our period. Trucker averages 600 miles every day, also speed. Difference between degrees and radians. So remember, a degree is a measurement for how far along a circle you have measured. Meanwhile, a radian is the radius taken and wrapped around the circle. So those two lines are exactly the same length. The relationship between them, that is useful to know. I would just memorize it. Pi rad equals 180 degrees. So this right here, memorize that if you need to go degrees to radians or if you need to go radians to degrees. So if you're going degrees to radians, then you're going to multiply your degrees by pi times 180. Explain arc length and arc angle. Arc length is going to be the length that you have traveled around the circle, similar to that radian. So it's arc length. We have a circle here. Okay, so the arc length will be in yellow, and the arc angle will be in red. There you go. State an equation that relates them. That's going to be your S equals theta times R, where S is our arc length. The arc angle, also known as angular displacement, times the radius. Angular displacement. Okay, explain the difference between linear speed and angular speed. Whew. Linear speed is our length per unit time. So we use meters per second, so it's length per time. Meanwhile, angular speed is going to be the angle per time, the arc angle per time. Arc angle is going to be measured in radians. So we'll use radians per second. You can use some other different forms of angular speed. But the symbol that we would use over here is going to be V. The symbol we're going to use over here for angular speed is this little saggy butt cheeks, as it were. omega, which is 2 pi over the period. Arc angle per unit time. So what is the relationship between V and theta? Well, let's look at this equation here. I'm going to rearrange this and solve for my angular displacement. So my angular displacement is S over R. S is just the linear displacement. Linear displacement divided by my radius. So it's my linear displacement, just like I did here, which was a length put around a circle. Length put around a circle. Radius, circle. My angular displacement can also be my length per unit time around a circle. So it's my linear version, which is velocity, around a circle, or over a circle. So this is V over R, my velocity over radius. Okay, so to summarize, if I took my linear average velocity, and that equals my displacement over time, and I wanted to turn it into an angular thing, I can do that. I now know what angular velocity is, and I know what angular displacement is. But first I need a bridge to get me there. So that bridge equation is going to be theta equals x or s over r. My omega is going to be linear over r. I have one more bridge equation, which I'll go ahead and put it on here for you now, but we haven't talked about it yet. And it's this alpha symbol. And that alpha symbol is angular acceleration. So it's my linear acceleration divided by my radius. So I could say omega equals theta over t, because my angular version of velocity is angular velocity, and my angular version of displacement is my angular displacement. So it can become this. Omega equals theta over t. There's more to this chart, but not yet. We'll get there.